I want the mean, I want the variance, I want the standard deviation. I want the mean. I'm sorry, I want the median. I also want the range. Oh, it doesn't allow me to select. Ah, okay. Median, range. I want the min, I want the max. I want even the mode. Let me see if I want anything else. Nope. And now compute. Okay, so let's take a look. So 54, the mean is 57 point variance. Standard variance, again, this is measurement units squared. That's really difficult to even comprehend, right, or use. A standard deviation, okay. The standard deviation has the same measurement unit with the mean. This one doesn't. Okay, the median, they all have the same measurement unit except the variance. Median, the range, minimum is 35, maximum is 85, and multiple modes. So that was our first question. Compute the population mean. So I'm on page 6. So here's for the HDL. I'm just copying down. I have n equals 54. I have x bar 57.407407. I have the variance, which is s squared, 139.37806. I have the standard deviation, which is s, 11.805848. I have the median, also called, we're going to discuss that very soon, called Q2. Q2. Median was 56.5. The range was 50. The minimum 35 and the max 85. Okay, so let me stop sharing for a second. So
did you say the median? Sorry, did you say the median was Q2?
Also denoted by Q2. Yes. Okay. Yes. You're going to see very soon. Now I want to, so this is my information recorded. Sample size, x bar, s squared, s, median, range, mean, and max. Okay, now I want to share my screen again and just look at, I don't need this. I want to look at the histogram now. I want the HDL. I want, it can be frequency or relative frequency if you want to discuss percentages, or frequency, or I don't think it allows us to do both. Let me see if what if I click both? No, it doesn't allow me to. Okay. And start at, the minimum was 35 and the maximum was 85. So I'm going to say start at 30. And the range was 50. I'm going to say the width of, so the range 50, 10 classes, that would be okay. Okay, I want the mean, which you already know is 57, and the median, which is 56. Okay, fine. And what else I want? Yes, I can label them. I can say the axis is HDL. And I want the y-axis to be percentages. Good. And the title. And the title is HDL and 54 females. Good. And there's anything else? No, just compute. Okay, here it is. Now, because the mean and the median are so close to each other, 57 versus 56, although you can say this is not appearing to be bell-shaped, it's pretty bell-shaped, pretty similar. pretty bell shape. It's not quite, it's an approximation. But as you see, this distance and this distance, so from 50, so from roughly 30, so this is about half and this is about half. Now here's the next question. I'm going to stop sharing. This is our first question here on this problem. Well, find the percentage of all patients, of females, within, you tell me, 1 or 2 or 3 standard deviations away from the mean, using the empirical rule. You choose.
Do 1 deviation?
1, very good. Within 1 standard deviation from the mean. According to the empirical rule, the empirical rule says 68%.
How many deviations can you do?
You can do 1, 2, or 3.
Right, just the 68.
Because for 3 you already have 99.7% of the data. For this one you have 95.
Okay, thank you.
And for the first one you have 68. Thank you. So 68%, we chose 1. So I have to write x bar plus or minus 1, but we don't write 1, just the one that we don't write. If it's 2 or 3, we have to write it. So this will be x bar 57.407407. Why so many digits? I just copied the whole number. We can go with just an approximation using 2 decimal digits, and I will write 41. That's fine. Plus or minus standard deviation 11.805848. So I will determine this with a graphing calculator or any calculator, and I will get the interval. And I will say, based on the empirical rule, and because of our assumption was that it was close to bell shape, this interval contains 68% of all observations in the data set. Any questions so far? $57.41. I'm just going to round it up as with 2 digits, and minus 11.81. And the other one 57, so the same thing, but with plus. So I got 45.6 and 69.22. So I can say, assuming that we all accept that this is pretty bell-shaped, then 68% of the 54, right? There were 54, so 54 multiplied by 0.68. So about 37 observations. About 37 observations are between this and this. 37 observations. Now, if you go back to the data, you may not find exactly 37 observations. So this is an approximate. So 68% of the 54, when I calculated, right, 54 multiplied by 68%, I got roughly 37 observations from those 54 females have the HDL cholesterol between 45.6 and 69.22. Any questions?
When you did that multiplication, you did the females and not the 57.41, right?
But this is, it says contains 16% of the all observations. Yes. Okay. So I had to multiply 54 multiply by 0.68, and this is how I got approximately 37 female. I'm sure that if you go back to the data set, you may not find that is exactly 37. It may be less or it may be more. The next question, but we ran out of time. So I had 2 more questions listed here as a reminder, but I will probably have to stop. So I want to determine the percentage of all patients that have serum and the HDL and this one. And also I wanted to illustrate with Chebyshev's inequality. So please don't forget to save this data set because I would like us to go back to it.